Hello and welcome to our online resource for Chapter 16, which is gas tungsten arc welding, setup, operation, filler metals. This is going to follow fairly closely to the chapter in the book. This is meant to be supplemental information, not meant to mean you don't have to read the book. You should read the book. This is going to cover the highlights and stuff that the book didn't do a good job covering. So a lot of you will probably already know some of this, but with any kind of welding, GTAW being very important, it's crucial that you really understand what's going on. If you don't understand what's going on, you're going to have a hard time making the welding process do what you want it to do. You'll have problems you can't figure out the answers to. It'll do stuff you don't like. If you don't understand it, you're going to have a heck of a time trying to correct those things. So this is going to be really key information. First off, what is GTAW? So GTAW stands for gas tungsten arc welding. Just like everything in welding, there's 2 or 3 names for it. GTAW is also known as TIG. It's also known as Healy Arc. Old timers call it Healy Arc. I'll talk about that in a minute. And what it really is it's complicated machinery making a very easy, not easy, but a very simple process. What it is an electric flame used to melt base metal and filler metal. Much like oxy fuel welding they did in the past, this is the same concept. It's just using a very controllable, very clean electric flame to do that. And the key point of this is that electric flame comes off of our non-consumable tungsten electrode. Tungsten is a very hard metal, and it has a couple of properties that make it ideal for TIG welding. One is its very high melting point. We can get it very hot without it melting and deforming. And the other one is its hardness. It'll keep a point for a long time. It really makes an ideal choice for this. The cool thing about TIG that I really like is it is truly a manual process. You have complete control over pretty much every aspect of the weld at all times. I really enjoy that. One of those things that flux core, I can turn my brain off. Stick, I can turn my brain off. MIG, I can turn my brain off. I can't ever turn my brain off with TIG welding. I've always got to be concentrating, and that's one of the things I really enjoy about it being so manual. So, TIG welding, GTAW welding, originated in the aircraft industry, like pre-World War II. They're trying to find a way to weld magnesium together, and at the time they were using a lot of helium. And the helium, it's an arc welding process. The name Healy Arc came to be, and that's actually a registered trademark of, at the time I believe it was linear union carbide, and so Healy Arc is like Bayer aspirin, whereas TIG is just aspirin. People interchange those terms a lot anymore. Most of the people who call it Healy Arc, they're not around much anymore, so that's going away, but you will hear that used from time to time. So the tungsten, and that's really, for me, one of the key parts of TIG welding is the tungsten. Let's see. Talks about it's got high melting points, got really good conductivity, it's very hard metal. We're going to have to shape it, okay? We do that in a couple of different ways. The easy way is in our prep room, we've got a tungsten grinder, a prong tungsten grinder. They work great. You'll also probably at some point use the bench grinder to sharpen it. And in the field, you might use an angle grinder and a drill. There's a lot of different ways to do this, but we're going to do most of it on our prong tungsten grinder. So when it comes to shapes, for me, I sharpen everything. In the old days, you would for AC, you would want a ball end, a nice round end on the tungsten, or even a little ball at the end. That is pretty much a thing in the past now. The new inverter machines, you can run a pointed tungsten on pretty much everything, even aluminum on AC, and it'll hold up really well. So for what we want to do, we want a nice sharp point, but not a needle point. We want to take that off so we have this tiny little flat spot out here on the end. If we don't have that flat spot, what will happen is as that piece of tungsten gets hot, there's so little mass out there in the tip of that tungsten that will end up getting blown off into your weld. And that's a bad thing. The mechanical properties of tungsten, the melting point of tungsten is such that when it's in your weld, it will always be a stress riser. It's be a stress concentrator when that, whatever it is being stressed and flexed. And usually cracks will propagate from that tungsten inclusion. It's always a failure on an X-ray. It's always a failure on a UT. And tungsten is so dense, it shows up so readily on both of those. You just can't have it. So we always want to make a nice, really small flat point on that. If we're running AC at really high amperages, we might want a bigger flat point on that. But for most of the steel we do, we want to make a needle point and then just knock the tip of it off. And the Piranha, we'll show you in the lab, the Piranha has a function where it'll take the tips off of them. The other important thing when we grind tungsten is the direction of these grind lines is very important. We always want the grind lines to go the length of the tungsten. Okay? That's what we want. What we don't want is a circular pattern with the grind lines going that way. This is what we want because as electrons move out off the tungsten, they'll follow these straight lines and they'll come right off the tip as a nice clean arc. They're going to get hung up on these things. They're not going to want to flow smoothly off the tungsten. They're going to try to jump off at multiple places down this, and you get all these weird little arcs. You won't get a pinpoint of heat. Doesn't work. So the Piranha grinder is set up to grind that way. The only way you can do this wrong is by doing it crossways, basically on the bench grinder. We'll show you all about that. Don't do that. We want nice straight lines on that tungsten. Tungsten alloys. This is an area that a lot of people talk about. You can make it as complicated as you want. You can make it as simple as you want. I like simple. I run 2% lanthanated tungsten for everything. There are a number of different alloying agents they use in tungsten. Lanthanum is one of them. Thorium, cerium, zirconium. There's a bunch of them. Each one of them has a different color code. 2% lanthanated is blue. 2% thoriated is red. I believe 2% ceriated is yellow or orange. They all work great. We use 2% lanthanated because it works really well for everything, even AC aluminum. So it just makes our lives easy. So talking about safety, 2% thoriated tungsten, which is the red band stuff, has been around since they've been doing TIG welding. And what they realize is that it's unlike the other additives to tungsten, it's actually radioactive. It's an alpha emitter. And what they've realized is that people, over a long period of time in a place where there's tungsten dust floating around in the air, they inhale these little particles of thorium, and being alpha emitters, they're constantly emitting radiation from the inside of you. It can lead to lung cancer and other things. So there's been kind of a movement in industry to push 2% thoriated tungsten out and replace it with either ceriated or lanthanated, which is fine with me. The lanthanated works great, but you'll work in shops where they still use thoriated tungsten. It's not a big deal. Unless you're emptying out the Piranha grinder and hoovering lines of it off the table, you're probably never going to have a problem with inhaling too much thorium in a modern welding shop. Places where they make tungsten, that might be a problem. For us welders, there's a lot bigger health hazards than thoriated tungsten. Probably what you ate for lunch is probably worse for you. So, shaping the tungsten, we talked about that. Direction of grinding is the key. We got to have nice straight lines coming from the tungsten to the end. They also make tungsten different sizes. They make it all the way down to like 40 thou, all the way up to 1/8. They might even make 3/16. Most stuff we're going to use is 332, which is a really good medium size. A lot of people, myself included, have switched to running 1/8" tungsten for pretty much everything. You just got to change kind of the angles that you grind it at. But 332 is really good until you get up to high amperage. We're not going to do a lot of high amperage stuff in the shop. So what you're going to be using every day is going to be 3/32 inch, 2% lanthanated tungsten. So we're going to make a separate video that's going to show the disassembly and reassembly of a TIG torch, where gas leaks happen, all that kind of stuff. Because we always have people with porosity issues, contamination issues. It's because one of their gas fittings has come loose.